Question 5. Maximum mark 6. A communication tower at T produces a signal, can reach solid towers within a distance of 32 kilometers. A straight road passes through the area covered by the tower signal, so that's represented by the grey area. And the road is the line SR. The following diagram shows a line represented the road, circle represented the area covered, etc., etc. S and R on the road. Point S is 38 kilometers from the tower, and angle RST is 43 degrees as shown. Okay, so let SR, so the line equal X. Let's just label that. So this distance here is going to be X, this whole thing. Using the cosine rule to show that X squared minus blah, blah, blah equals 0. Okay, we'll come back to B in a second. So it's worth 2 marks, but it's a cosine rule. And the cosine rule applies to triangles, any triangle. But I don't see any triangles at the minute. If I drop a line down from T to SR, I'm going to get a right angle triangle, but that's not going to help me. But the thing that I am really interested in is this line here, TR. TR is a radius and is worth 32. I do want to rejig. It's my paper. I'm going to write all over it as I advise you to do, because the cosine rule states that a squared is equal to b squared plus c squared minus 2bc cos of A. But we don't have the letters A, B, and C, so I'm going to force my letters to be A, B, and C. My A is going to be this value here, because that's where I've got the angle, and it doesn't matter about the other two. So I'll let this be angle B, and this is angle C, which means this is little c, this is little b, and this is little a. So we forced it, so we should be able to get into a position where we can answer A now. So A squared is 32 squared, and that's equal to X squared plus 38 squared minus 2 times 2 times X, and C is 38, and then we've got cos of A, cos 43 degrees. Let's just check where we're at. So we've got the cos 43, excellent. Can't see a 420 yet, but we've also got the X squared. That's good. So let's just keep going. So 32 squared is 1024. That's equal to X squared, and 38 squared is 1444, and then 2 times 38 is 76, so we've got negative 76, yay, okay, good, that's coming out now, cos of 43, we're on our way. Right, if I subtract 1024 from both sides, that's going to leave me with 0, which is what we need. We're going to have X squared. 1044 minus 1024 is going to give us 420, which is the value that we need now in the question, minus 76 cos 43. Is that the same as that? Yeah, it's just in the wrong order, so let's rejig it. So 0 is equal to, 0 is equal to X squared minus bracket 76 cos of 43 plus 420. Okay, so that's the important line. We need to show that step in order to get the full value. So where do the marks come from? We have an A1 for recognizing TR equals 32. So here, let's do it in orange. Here, this is an A1. And for the correct working, so probably this line, this is going to be an A1. You must show this line in order to get, so that would be marked as AG to get the solution. So let's move on to part B. I'm just going to jump onto the next bit. Hence or otherwise, find the total distance along the road where the signal from the tower can reach the cellular phone. So we already know that this value is 32. I'm going to mark this line in as well. That's 32. And I'm just going to maneuver some values. What do we know? So the first thing we want to look at is the big triangle. I'll just sketch it out here. So we know that this is 38, this is 43, and this is 32. We do know that that is X, and we know we know how to work that out if we so desire. What I'm interested in though is if I can find this angle using the sine rule. So sine of 43 divided by 32 is equal to the sine of, let's call it that, over 38. So theta, once you rejig all of that, gives us a value of 54.0835. You probably need to go away and work that out. In calculator, that's absolutely fine. Why did I work that out? Well, I worked that out because in my next triangle, the triangle I can see is this here. So I know this angle is 54.0835. This side is 32 in length. This side is 32 in length. So we have an isosceles. Sorry, people are escaping. This angle is also 52.0 blah, 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 blah. And I can now work out this angle. Let's call it alpha. So alpha is equal to 180 minus 2 times 54.08.0835 degrees. So that should give us a value of 71.8329. I'm just going to get rid of this top triangle. I need the space. I'll probably have to come back to that triangle though, annoyingly. And then if we rework the values, we're trying to find what the distance is. So the distance over sine of 71.8329 is equal to 32 over sine 54.0835. When I'm typing these numbers into my calculator, I'm using the whole thing. I'm not using the 6 significant figures. I'm using the whole value that my calculator gives me. Revaluating that, D gives us 37.5427, which tells us that D is equal to 37.5 kilometers. There are other ways of working that out. I saw it through 2 triangles. I've used the or otherwise. You can substitute those in and find out what x is at that point. Where do the marks come from? So recognizing isosceles triangle. So this value here, this bit is worth an M1. Correct working to find the distance. So that would be here. This is an A1. And then we have 37.5 kilometers is also an A1, but now I'm missing a mark. Oh, and the 54, sorry, 54 is an A1, so there's my 4th mark.